Alright, this video is section 4.3. We're going to solve quadratic equations today using only simple factoring. So we're going to start off with a quadratic equation in intercept form. And this is often called factored form too, because this is what it looks like when you're finished factoring. But if we started out with this and we wanted to change it to standard form, we would have to FOIL it. And just as a quick review, that would be x times x is x squared, x times negative 3 is minus 3x, 2 times x is plus 2x, and 2 times negative 3 is minus 6. So we get y equals x squared minus x minus 6. So that would be our standard form. But if I gave you an equation, a quadratic, in standard form, and I told you to put it in intercept form, then the way to do that is you have to factor. Now the best way for me to explain this is to just go through it using an example while I do it. So say we have y equals x squared minus x minus 6. Well, a is 1, and b is negative 1, and c is negative 6. That's for our ax squared plus bx plus c. Right? A, B, C. So what you want to do is you want to look at C. You want to look at that last number, and you want to find factors of C that will add together to give you B. So write that down. And keep in mind that this is only the process we're going to use when A is 1. We'll do in the next section, we'll do some factoring where A is bigger than 1 or different from 1. But just for our simple factoring, we're only going to do this for A is 1. So in this case, we've got C is negative 6. So if we were to make a factored list, you can either do this in your head or you can do this on paper. But it would be negative 6 times 1 or positive 6 times negative 1. We would have negative 3 times 2, or positive 3 times negative 2. And that's it. So if we were to add these up, negative 6 plus 1 is negative 5. 6 minus 1 is positive 5. Negative 3 plus 2 is negative 1, and 3 minus 2 is positive 1. We want this to add up to negative 1. So we want to use this set right here. So we want to use negative 3 and positive 2. Once you've done that, you just use those as your P and your Q in your factored form. So your factored form is y equals, and then it's going to be x minus 3, and it's going to be x plus 2. Because if you were to FOIL this back out, you'd have x times x. Let me use this little pointer here. X times x is x squared. X times 2 is 2x, and negative 3 times x is negative 1x, and negative 3 times 2 is negative 6. And so if you notice, we started with this when we FOILed it out, and that's what we ended with. So that's how you factor. It's pretty simple. I'm going to repeat myself one more time. All you do is find factors of C that add to get B, and then you write x plus one of those factors and x plus the other one of those factors. That's all you have to do. All right, so second period wants to say hello. Everybody say hello. Hello. Hi. Okay, so third period wants to say hi too because they're jealous and they get a video. So everybody say hi. Hi. Okay, so moving on with the real math now. I have some stuff you probably want to write into your notes. Solutions of a quadratic are called roots or zeros or x-intercepts. They can be called all of those things. Solutions, roots, zeros, or x-intercepts. It all means the exact same thing. And that all is where the parabola crosses the x-axis. To solve a quadratic by factoring, all you have to do is factor the expression completely, and then you're going to set each factor equal to 0, and you're going to solve. So you'll just set each little piece, just like when we did intercept form and we found the x-intercepts. And then if I ask you, if the problem says, tell me the solution, or what are the roots, or what are the zeros. You can give me x equals 2, x equals 7, whatever. But if the word is x-intercepts, then those are clearly points on a graph, and you must put them in the form of an ordered pair. All right, and finally, I'm going to do a couple of examples just because this video is super short and you need some. All right, so if I said factor the following, then you would look at this and you'd say, all right, C is negative 18. So what are factors of negative 18 that add to get negative 3? And you go through all the factors and you say, well, 6 and 3 makes 3 if you subtract them, so I want to go negative 6 and positive 3 to equal negative 3 here. And negative 6 times 3 is negative 18. So I'm going to factor it to x minus 6 and x plus 3. It's that easy. Here's another one, n squared minus 3n plus 9. So we're going to say, what factors of 9 add to get negative 3? And I'm thinking, the factors of 9 are 9 and 1, and that makes 10. And negative 9 and negative 1 makes negative 10. And 3 and 3 makes 6, and negative 3 and negative 3 makes negative 6, and those are the only factors 9 has. So if there are no factors of C that will add together to get B, it is not factorable. Not factorable. And that was what you would write as your answer. And if you were asked to solve, for example, x squared minus x minus 42 equals 0, if we wanted to solve that, then we would need to factor it. And factors of negative 42 that add to get negative 1 would be negative 7 and positive 6. So when you're solving, you just set each piece equal to 0. So x equals 7, and x plus 6 equals 0, so x equals negative 6. X is negative 6 and 7. Like that. And if you were asked to find x-intercepts, you would still factor. So factors of negative 14 that add to give me positive 5 would be positive 7 and negative 2. And so you do the same thing. You set it equal to 0 because the x-intercepts are where y is 0. And so we know that x would be negative 7 and positive 2. But since I'm asking for x-intercepts, I'm asking for points on the graph, and you would write negative 7, 0, and 2, 0. You would give me the ordered pairs. Alright, so that's it for this video. Tomorrow we will be doing more complex factoring, so make sure you master this easy factoring, and I will see you tomorrow.